Trachandrena, which traditionally has been sort of a nightmare. And I actually still, I have to admit, I rarely identify any of the males. They're just Trachandrena spa. But the females, we have a pretty good handle on, but it's tricky enough that we developed a spreadsheet, which I think is more user-friendly than either a dichotomous key or the Discover Life keys, because there's so many ambiguous characters involved, and you really often need sort of what is it called when you accumulate all sorts of vague evidence. I'm going to share now, go to the Excel spreadsheet. I figured this out. Click on that. And, ooh, I have too many things open, don't I? As usual. Okay, here we go. So everyone should have this also. This is a good approach to take for your own work, because you can set something up like this for any group of species that you're having trouble with if you like this Excel format approach. So think about it for whatever your identification needs are for a particularly troublesome group. So again, we're dealing with Trachandrena, we're dealing with east of the Mississippi. Mike's going to come on here in a second. He probably is aware of a couple more species maybe that should be in here, but for now, this is the bulk, maybe all of the species east of the Mississippi. Another nice thing is you have this, you can modify it however you want, and you can add additional Trachandrena species. So we'll look at a Trachandrena. We're going to start with Andrena forbesii, which here is one of the most common species, and use it as a format for talking about all the others. And in general, what we're looking for, and we'll show these. The Trachandrena is going to have a propodial triangle that is clipped at the end. So in other words, there's a raised line that goes all the way across the tip where it moves down below the surface of the dorsal part and goes on to the part, the ventral, if you will, the part that's facing the abdomen. And the interior of that clipped section is filled with raised lines. So people might call it reticulate, striate. There's different names, and we'll again get into a lot of that detail. So that's number one character. But a couple other species, I'm thinking of Andrena illicus, I believe, or I confuse the two, Andrena illicus or Andrena, not illini, but there's another one begins with I that could have it. That's not a Trachandrena. And then the second character, the depressed rim of T2. So T2, again, we're going to see this, but just to lay it out. T2 has, in almost all bees, a section usually near the rim. This is not the case for Trachandrena. That decreases very slightly in elevation, so that's the depressed part. And you can see a vague ridge that defines where that depression happens. Usually abrupt, but fine. In other words, it's not a huge change, but you can see it, particularly if you're shifting your specimen around to highlight it. And almost all species have this, bees, that is. And different places and different times, it's more or less useful. It's rare to see what we're going to see in Trachandrena, where that depressed area is covering sometimes up to 90% of the T2, what would that be, longitudinal length. Again, we'll see this. And then a further character, if you really need to, or you can't see the others, that helps define what the group is if you look on the face, these are females again. If you look on the face, the facial fovea. Is Sydney here? Could you take it? Sorry, we're having water issues at the lab, and that was our facilities person. So the other character is that the facial fovea are deep. That's not that unusual, but at the lower end, it narrows way down, often to just a tiny little slot. And in many of the species, it's removed from the inner edge of the eye. Again, we'll see all these kinds of things. So that combo is what's going to define Trachandrena for us. And is Mike on yet?
No.
Okay.
I'd say just run with it. No.
We're going to run with it. So now to the spreadsheet. What you're looking at are just alphabetical order for the species, as rows and columns have different characters. And some of these characters are a little ineffable. In other words, you would never count on them to do an ID because it's descriptive in some ways, but it's useful to see if everything lines up. So if we look here, we're just going to go through the columns, if I can do this right. F2 length by width. So that's pretty obvious. It's just a ratio of length to width. Here's a column in C that talks about what other species are similar to this one that you should also contrast. And the vertex height, so that's the distance from the rear part of the ocelli to the rear of the head. We'll again look at that. And then we have surface below central ocelli. So this is the patch. Gosh, I forget. Is it called the frons? I can't remember. But if you look at the ocelli, you have the lateral ocelli and the central ocelli, and you look at the patch of integument between the ocelli and the antenna, there's stuff going on there. Basically, you're differentiating smooth and glossy, like you can see it, and an area with some kind of striations. Then the next, facial fovea fat to thin ratio. So we talked about these fovea being deep, which they all are, and the upper part, which is near the ocelli, then we're comparing that and contrasting that to the section down by the antennae. So what basically is happening is you have many species where the top part is fat and then it necks way down to just a skinny little trough below. Much more radical and dramatic than many of the Andrena species, but not every one, right? So that's why it's a useful character. Fovea description. So this has to do with, and you can open these things up more, whether the area, in particular below the ocelli, whether it's bowed out or bowed in. So, or straight. So it's the shape. Then we'll move this a little bit. There's a lot of characters, but again, a lot of these bleed into one another. So fovea max distance to rim of eye. So if you're looking at the inner rim of the eye, you're measuring the distance from the edge of the eye to the start of the fovea at the area of the antenna. So what we're basically looking for is sometimes it's close and sometimes it's so bowed out that there's a big distance between the two. Another useful thing. Here's pitting. We've talked about this many different times. Sometimes pits are dense, sometimes they're not dense. Here's the characteristics of the internal triangle. So that's the propodial triangle there. Rectangular versus not rectangular cellular structure between those tall striations. Border of the triangle. So sometimes on the triangle itself, there are very clear raised lines, very sharp demarcation from the internal part of the triangle and then the exterior. And sometimes it just bleeds out. In other words, there's no real clear line. And other times it's very crisp. You have a very sharp line that defines the inside and the outside of that triangle. And moving on to more and more places. And then these the sculpture inside the triangle, so the striations, the raised lines and everything, in comparison to the adjacent area outside the triangle. So sometimes they're very similar, sometimes they're quite different. again, a lot of these can be, you can get like, I'm not sure if they're quite different or not. So that's why we have many characters. We're looking at the hind tibia tarsal segment color. So one species in particular, this is a gimme for Hippodes, is orangish on the tarsal segments, tibia too, at least part of the tibia. And then the tergite color. So in one case, you can have a very orangish specimen. So this is Marie, which is generally thought of as a willow specialist. And of course, sometimes it's orange. Those tend to be the more Midwestern and Western species. And sometimes it's dark brown. This is the version that we get. So useful if orange, not useful if not orange. T2, so this is what that we were talking about. This is the proportion of the area that is oppressed or depressed or has the depressed rim. So you can see it varies from here to almost 90% to areas that are about half, and here's 0.4%, but still always significant. Most other species you would be talking about 15%, something like that is pretty standard among Andrena. So just a narrow oppressed line. T3, 2 and 3 hair along the rims. These are almost always, I don't think they're ever complete. In other words, there's never a complete hair band lining the rim of bright white hairs. But in some cases you have none. In other cases you have patches that can be quite distinct. And then sometimes it seems that either things are wearing out quickly or there's variation or we're missing some other species that is hiding within there. You can get, like you can see here, none to distinct. Pitting on T1, same thing. These are in pit diameters apart. These can be incredibly close. So here 0.25 to 0.5 or 0 to 0.04 or to 0.4, meaning 0 meaning they're overlapping, to really sparse, 3 to 3, much greater than 3, so hardly any pits. Here's some distributional stuff that can be useful. And then over here is our miscellaneous category about the species group that could be influential in helping determine how to tell them apart. So we'll leave it there for now. I'll also just mention as an aside, we also have done this for Melandrina males, another sort of tricky group, and we can have another session on that one. I guess maybe we'll just, and Claire, you can tell me if anything's in the chat. Any questions about the approach at this point? Okay.
I think the only thing that might be worth clarifying is that we are always dealing with Eastern, but you do have these continental species on here that may be misleading in terms of, are these the only, like where do we draw the line again? And in terms of like what kind of abundance might we expect west of that line?
Oh, yeah, there's going to be, I don't know the
or
numbers.
richness, not abundance, but you know.
Yeah, I don't know the numbers. There is so we're using still LaBerge's old definitions of subgenera. You can go online and click your state on the Discover Life keys, click your state, and also click at the bottom. There's a character for subgenus, click Trachandrena and see how many species names come up. Or you can just take off all the states and click on Trachandrena to see how many. I haven't done that. How many are there? Almost certainly the Western sections will have additional Trachandrena. So, or right, they need to justify their existence. Go to a museum, borrow a microscope there, or bring your own. Find the additional species and add them to this. This send it to us, and then we'll keep it there too. But that would be handy. But we are making only claims that this represents things east of the Mississippi. So there's no other questions, but we can take questions anytime. We're going to go to a specimen. So we're going to do for Bessie. So a couple things here. These yellow marks, these are sort of for each species, these are a key set of characters that would define that. Oops, I went too fast. That define that species. If we're here at Rennie, you can see like, oh, sometimes it's obvious, sometimes it's not. Here we have a very long F2, and then we look here, the vertex height is also quite long compared to others. And if we keep going, it says, oh, the cell structure of the triangle is not rectangular. That's unusual. And we see that pitting on T1 also very sparse, 2 to 4. And so the yellow markings highlight key differences that help separate out each species from other species. You also have, if we look here, we see Rennie, which is a chestnut specialist, is so specialized that there are no other species, or so easy or distinct, if you will. There's nothing that's really close to it. So we'd have nothing in that cell that says similar to, because it should be, that combination is pretty darn unique. Whereas others, it's like, well, we might have to look at a couple things here and think a little more deeply about some of these comparative values. Okay.
So we do have 2 questions in the chat I'm going to bring up.
Okay.
Our friend Eric asks about the date captured coming into play at all.
There is information there. I didn't add it. Like for example, Nuda here is, oh, was that Kalides Nuda? Never mind. I'm backing up. I think in a couple of the notes, like Miranda is a very late in the season species. Here, like summer. But I have not done, so that would be nice to add if someone wanted to go through and compile the records. There are likely patterns here. I want to say in general that this group tends to be later rather than earlier in spring, and some bleed well into summer. Rennie, for example, just because I know when chestnut blooms, which is now, this is basically the edge of summer, so late spring, early summer, and some of these others would be out earlier. But I can't completely answer that. But if someone wants to compile the records, GBIF is a great place to go for that because they tabularize the records. But of course, you have
Eric follows that up with, I think, what you kind of just addressed.
Uh-huh.
For the sake of the recording, would a specialist only be present during that pollen season?
Yes. So we mentioned, I think Maria is thought to be a willow specialist, so it should be out during willow bloom time. One of the interesting things, though, about willow is you can have blooming willow from super early in the spring. So that would be something like Flissy willow, I think, is one of the very first ones. And then you can have things blooming well into late spring. And additionally, like in the Dakotas, for example, in May, it's still full bore willow season, whereas in Maryland, that's pretty much over. So you have to calibrate by your latitude too, and whether you're continental. In other words, the Midwest, in the middle of the Midwest, is colder because it's not got any oceans to warm things up. But yes, and I just don't know enough to know how useful the dates are going to be. But it would be a good column because, again, we're looking at weight of evidence kinds of approaches here.
Another question in the chat.
Uh-huh.
Back to that, like there's a lot of stuff in this group that we might not be able to get to species. What are best practices for specimens where one cannot determine for certain which species it is?
Yeah, good question.
Etc. I'm going to throw in, have you the data?
Yep. Yeah, no shame. And also you want to be conservative. Like, oh, I'm looking at Hippodes here, and I'm, I can tell it's either Hippodes or Miranda, but I can't tell, and I can eliminate all the others, but I'm really not certain about that. So there's two things. One is you could put, but maybe you actually have a strong leaning, like Andrena Hippodes, pretty good, but maybe not 100%. Andrena Hippodes question mark is sort of an indicator, like that you feel like it's Hippodes, but you still question yourself. So if you enter that into the database, then people can see that, and then they might, for example, they'd say, oh, I see you have a possible Hippodes. Maybe I could look at those. Maybe you could send them to me, and then I can tell you what they are, or maybe they're useful for molecular stuff. And it also denotes more information than Andrena species. The other way is if it's like a toss up, or you just can't find, like we always, as an example, not with the Trachandrena so much, but with Andrena imitatrix, further to the east, but basically the whole east, there's also Morrisonella. And in Mitchell, I want to say, or maybe it's even, I'd have to go back and look whether Wally LaBerge did this too. Like the males are thought to be indistinguishable, and the females have one character, which is the amount of whether the hair internal to the corbicula on the side has branches or not. If I recall, that may be the only difference. And I'm after these are very common bees, and I just feel completely uncomfortable splitting them. So everything in our database is imitatrix / Morrisonella, and that's how they're entered in the database. So I would hope that, so that way, so for example, if you do Andrena imitatrix / Morrisonella, it's one or the other. Like there's no ambiguity that it isn't one or the other, but you can't tell which it is. So another common group to do that, which is Halictus legatus / Powei. So for that group, although we're working on a way to tell them apart, if you're in the mid-Atlantic area or the upper South, you can't really differentiate the two at all. But both are present and not well defined molecularly in terms of actual distributions. And we, as an aside, we have some ideas, but we have to test them. So you really can't put down a species name. You have to, I think, right now, given what everyone knows, put legatus / Powei. But it's one or the other. Does that explain it? You think, Claire?
I think so. It's in the chat for you.
Yeah, good. Okay, so let's go to a Andrena forbesii and see if we can walk through these things and see them. Let's see, where the heck is there it is. Okay, so I'm going to put this on full screen. All right, let's see, was it F? There we go. All right, it's walked a little bit in terms of magnification. So I did the abdomen first because again, I want to show a couple of the characters that define Trachandrena. And then we'll get into specifics that split Trachandrena apart. So here is the depressed area in Forbesii, which is roughly half or 0.6 or something. What you're going to see, so for example, you just look at pitting, there's not a whole lot of difference. In some species, I don't know about Trachandrena at all, when you hit the depressed area, the pitting changes density. Here, it does not. This is all basically uniformly, very closely spaced pitting. And here you can kind of see, I think, even on this relatively poor screen, and we can change the lighting a little bit, maybe, to see if, here I'm going to turn off the main light, if a scans, it doesn't really help, does it? I think it's visible. So here, and we'll see other specimens that look like this. So we'll see this depressed area here. So this if we actually looked at the elevations. This is a little bit higher, this is a little bit lower. You can see these lines. Here it is on T3. We don't use T3 characters, but it usually mirrors T2. So that's one feature. This would be a relatively short depressed area. A lot of the others are way up here. We'll see that. And sometimes a little stronger, sometimes not. Okay, now we're going to go to one of the other general features for Trachandrena. Not definitive in itself, although the depressed rim has that. And so what we're looking at here's a propodial triangle. Recall that the tip of the triangle usually I'd say, always bends over to the vertical face T1. Okay. The difference here is that there is a raised line right at that bend, right there. Maybe a little bit difficult to see. Can we change this a little bit? I'm not sure. Maybe we can go up a little bit in magnification and see it better. I'm going to move it if I can. That, again, there are maybe one or two in the east species, all very uncommon, that have a raised line here too. So we see that and we go like, oh, I'm probably looking at a Trachandrena. Look at the abdomen, check to see if the depressed rim is long. Let's flip to the face and see another relatively good character for the group. And
SCIF, right?
this is for Bessii, yep. And the important thing here is, what is the important thing? Is we're looking at these as general characteristics. And so if I can move in here a little bit, we've got, I think this is visible. We'll look at the other side too here. So here's the facial fovea. Facial fovea filled with mysterious short hairs that are usually visible, sometimes different colors. And here's the outline. These are relatively crisp outlines because this fovea, not well defined in this picture, is deep in comparison to other species. So there's more of a deeper impression, more like a swimming pool, I guess. And so we can see the edges quite well. Here, these long hairs that are sticking out of the front of the bee are interfering with seeing the bottom part. We'll try and find that. But here's, just for reference, here's the rim of the eye. Here is an antennal socket down here. And when we go across here, we see that the edge goes interior and bends to the inside and then comes back down. So I'm going to try and look at this on the other side too. And here is integument, quite a bit of integument between here. And we usually then look at how much of this integument in comparison to the width of the fovea is there and put that as essentially a percentage. Because sometimes this is way out here and this area of the lower part is quite narrow. And other times this is fairly close, fairly straight, and the area is wide. Just so you know, for this species, the ratio of the upper part to the lower part is, I think we gave it as 0.2. In other words, there's not as much of a reduction in the facial fovea dimensions as you go further down. So this, even though they're still quite distinct from other species, which tend to just have a big sort of oval, right? There still is architectural elements that cut in. It's not as great as some of these others. So let me see if we can see this better. We'll see it on others. Here's the other side. It's a little bit visible. I think always we run into problems with these hairs here that are generally always on Andrena and seeing the bottom part. So the good thing is that this is such a well demarcated hit fovea, whatever you want to call it, that usually you can see it right through the hairs. Here in this case, we can't, but you can see here's the line, there's the eye right here, and here's the line, and then it cuts in. And so here's this bare space, and we look at that and say, oh, what's that percentage? So those are the key features that will tell you I've got a Trachandrena specimen here. You can use the Discover Live key. The problem is, as you just saw from that Excel spreadsheet, there's all sorts of information going into separating out the species within this group that it gets pretty confusing. You can also try and use Wally LaBerge's key, which will include all the Western stuff. And I haven't used it in a very long time, so I can't even speak to how well it does. And it sounds like Mike is not here. Not here. Okay. All right. But yeah. Well, this is not a one-day shot here for sure. So let's go back now, and what we can look at are some of these characteristics. Like some of these, I don't think we need to do this. When we do look at for Bessie eye, we can see, as most of these are, that we have an F2 length by width that's 1:1. So, I mean, what's to show? We kind of know what that looks like. Here's the similar species. We might contrast that at the end. Vertex height, when we look at the sweep here, this is on the low end, but it's not outstanding. We have a lot of species here, so I don't feel like I need to show some of these things that we've seen in other talks. So we'll say, and it's also not yellow. The surface below the central area has some pitting and no clear striations. We're not at this one. So we actually, I have that up. So here we can see what that looks like, but it's basically like a lot of things like, oh, there's some pits there. So this is the area right here that we're looking at. Sometimes there's these striations. So like sort of like the propodial triangle, and like, oh, there's something going on there. And then in other cases, you can see, let me bump it up a little bit. We can see quite a bit of what can be called shagreening or microscopic lines that dull the surface. So there's the pits, and in between is a lot of stuff going on that has dulled the surface, so it's not reflecting a lot of light. Different names given at different times, but that's what we're talking about here. So, but that's not a character that's a key one. So here, this facial fat to thin ratio. So this is what we were talking about before. If you take a look down here, you can see a lot of them have some pretty big fat to thin ratios, but you see quite a bit of difference. But here we're saying that the fat to the upper part compared to the lower part is only about twice as fat or thin, or 2.5 times. We saw that a little bit. Let's just jump back here. And again, we have the often tricky problem of seeing the lower part on these kinds of microscope lenses because of these hairs, but you can see this very easily under the microscope. So this area, so the width of the lower part to the width of the upper part at their greatest and narrowest, and you can see roughly 2 times difference, 2.5 maybe. So in the scheme of Trachandrena, this is not a very um, uh, differentiated, or this does not have a very high ratio. So it doesn't tell us a whole bunch. But that's important because we're saying, oh, here is a not super thinned out fovea. And we saw that area in that previous picture, and when we talked about earlier, the thin area is slightly bowed inward. So in other words, we look up here, thin area straight down from the upper part. This is bowed inward. So in other words, there's a gap between the edge of the eye and the fovea. And if we look at the fovea distance from the rim eye, so this is at the level, you can see, and also I should point out, if we look down here, there's a little explanation. Again, you get to do whatever you want with this. So you can add more explanations. You hopefully are writing in your own notes into your version and adding to this. And we would love that you become taxonomists doing these kinds of things. It's an open system. Anyone could do it. So here, measured in units of the width of the apex of the scape. So actually, isn't that a little bit ambiguous? So if we go back up here, we're on the species. So we're saying that that gap between the eye and the edge is 0.5 to 1 times the width of the apex. Although I think that my definition is wrong here. Apex of the scape would be at the top, which would be up at the upper part, and that I think I'm talking about more at the level of the antenna. I'm going to have to go back and investigate that, but I think I am incorrectly portraying that. But anyway, it's not that big. Here you can see some honking big things, 1.2 to 1.6, 1.2. Okay, here's another one that's a key characteristic. So scutum pitting. If we see it's 0, so they're all touch pit open between the tufts. So let's take a look at that and spin this down. How are we doing on time, Claire?
About 20 minutes.
Okay. And this is a slow, but I think that's a good enough angle here. So in this particular one, we certainly aren't touching one another, but we're also not very, I'm going to take it up even more. But you can see that the distance, the gap between those on average is very close. So most of them are, a few are touching, but most are, within half a pit distance from another pit. So what we're saying is a lot of pits very close together. And that's our measurement, is in pit distances. Now, when we look at the internal propodeal triangle, might as well do that. We're going to see that it has a structure to it that is mostly rectangular, not sort of all over the place, which a few species do. So this is what we're going to see here is sort of the standard presentation, not the one that you would say find helpful in defining this species. But for other species, it's good. So what we're looking at are the propodeal triangle again. We're looking at the cell structure. And in general, there's a rectangularness. You can't quite see all of it back up here, but these areas are mostly chunked out in rectangles. Not perfect ones, but it's there's some linearity here in the edge of the propodeum. Oh, you can see the in this particular angle, you can see now very crisply the carina that defines the edge of the propodeal triangle. And you can see that the triangle extends further down. Can't see it well, be over the edge here, but it is not, because it is cut off by this carina, which helps define the species group. All right, if we go back here, we can look at the borders of the propodeal triangle. Note this is in yellow, so this is a good, you want to see this character if you're going to make a definition of this being Forbesii. And we can see, so here's the border here between the outside and the inside, and we can see that it is nicely defined by a raised line. So there's no ambiguity as that this is the inside of the triangle, that's the outside of the triangle. There's a line dividing both. So present and very clear. We saw that, yay. And then we also can look at the outside sculpturing outside the triangle is much finer than the inside of the triangle. And I think I will change the angle on this so that shows up a little bit better. You can kind of see that already there. So in some species, that level of sculpturing is about the same. And in other species, it's quite a contrast. And the other thing is, like with many insect specimens, sometimes you can see well a character and other times you can't see well. So it's nice to have duplicative characters that you can count on to separate out the species. So here, so finer structure. So first of all, there's no rectangularness. These have big gaps in between, and these are similarly rugose, we would call it. So bumpy, has elevations, topography, but it's at a finer level. So I think and there's our nice crisp line. There's our edge to the tip. So I think that's pretty easy to see. We don't need to look these up. The colors of the body parts are, in this case, both dark brown. Now the oppressed area, 0.4 to 0.6. We saw that, but let's go back again. I'm going to do it from a slightly different angle. Maybe this will show up better on this one. And take it down a notch. And so T1, T2, here's the depressed. So in some cases you might say, oh, well, that's a tergite rim, but it's not. You know, you can see that there is a structural difference between the tergite rims and the non-tergite rims. But this is a very pretty nice view of the edge of the depressed area. Actually kind of disappears when we elevate it to higher magnification, but let's see if we can go, there we go. So yeah, you can't really see because it's so small a difference in height, but there's a line that shows up and we can see that this distance compared to this distance, again, taking into account that abdomens are like accordions and sometimes the abdominal segments get retracted in and retracted out. So the amount that's showing here isn't always the same just because this segment can slide under this segment. But that's why we use T2 more because it tends to do that less than the lower abdominal segments. But if we look here, we have something that's roughly probably 0.6 in this case compared to the entire width. And so that fits our definition here of proportion oppressed. It's not a highly colored one, but it's also you can make it a colored one. You can say that's a character I want to see when I see Forbesii. And so here we have varies from none to distinct. So when we go back down, see this a little bit better. So it's on T2, and you can see on T2 that there is a patch of hair there, bright white hairs at the edge. It's not very big. You can see how it could be worn off and maybe in some species not there at all. T3 doesn't even look like it has it. So you can see the amount of hair there quite easily. Okay, now when we go to T1, we also have a nice yellow feature to look at that helps us define it. So here, the pitting again, super dense. When we look at a lot of these other species and we don't, rarely are we even close to that degree of density. In fact, we see none of the others going to 0 or touching. So you would want to have a specimen of Forbesii be incredibly densely pitted on T1 to again meet the definition. And because it's a tricky to ID group, there could be more species out there. We don't know, but seems to basically work right now. And you can see some of these are overlapping. The rest are very close. If we look at this shinier area in the middle where things are a little bit more defined, it's like, yeah, they're almost on top of each other, and sometimes they are. So that fits very nicely with that character distributional stuff. So you can get, and does not have the bent tibial spur like Sigmundi. So if we go all the way back here and we say, what's it close to? Marie and Sigmundi, I have to say, Sigmundi, I wish Mike were here, but we'll have to ask him. I have a tremendous, this might be another willow specialist, I can't recall, but I have a tremendous time determining any of these, like the specimens that were available at the Smithsonian. I'm looking at the tibial spurs and going like, I can't see that feature. It's supposed to have a bent tibial spur. And if we look across here, so you can do things like, let's see, we want to look at Forbesii. Well, let's highlight everything between Sigmundi and there, and we're just going to right mouse that and hide those rows. So, and you can do this as you work through this worksheet. You like go through and like, oh, this does not have that character, so I'm going to hide that row and keep going until through process of elimination, you're down to whatever you want to look at, or you can play around like this. Like, okay, for Forbesii versus Sigmundi, let's look at these two and just go back and forth. Pretty much the same, pretty close, you know, they're overlapping. Yep, overlap, pretty overlappy. Scutum pitting says 0, 0, all very much overlapping, 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 overlapping. Well, this says none to vague and thin, and this one was definitely distinct, although it also says none. So under some circumstances could be overlapping. Here, though, we have a difference, but again, a little, you know, this is pitting on T1. We definitely saw 0. Here, there is no 0. And then here is the big difference that's in the keys about having well, my notes here say hind tibia may be more cuneate. Maybe is the operational. So that's, we look up here at the full thing. Inner tibial, hind tibial spur with bend or kink in it that makes it appear slightly S-shaped. And then I also point out, very hard to see. And I have to admit, I have not really been able to grasp that one. Whereas other times, like Andrena macra, I can see that twist in the tibial spur. It's pretty clear. So, but for a couple reasons, it does look, you know, like this one in particular, it does seem like we definitely have Forbesii. We can also now unhide these. You just click on a row, go down, and then should be able to hit unhide. Look at that. Back. Let's look at our Forbesii and Marie, and we'll get rid of these two. Oops, do the whole thing. Hide them. And now we'll do the same thing. Well, first of all, the tour guide color is definitely not orange. It's brown, but Maria can be brown. So haven't quite eliminated that. Overlap, hair. Oh, wait, we want to go further back. Okay, now we're in full control. These are linked to, in other words, if you click on that name, you'll go to the species page. So here, overlapping, But on this one, we do have something that's different. And what it is the surface below the ocelli, and it says clear striations with only vague pits. Well, that was definitely not the case, right? We had definitely had this pitting very close and no clear striations. So already we've been able to eliminate that. In fact, it's a thin fovea thing. We're at a ratio that's a slightly different, and but not a whole lot. Slightly bent outward, relatively narrow compared to other species. The intersection goes straight down. So again, I think we can eliminate Maria E already. So I'm not quite sure why I said it was that close, but it is apparently a little bit close. Again, not orangish to dark brown tergites, but T2 overlaps, short bands, pitting 1 to 3. So that's quite different. Okay, so I think we don't need to worry about Marie anymore. And I'm going to unhide these or I'll forget to do that. And I guess at this point, after having gone through one, I'll ask if there's any questions. And, okay, hang on, let me do the unhide thing.
Rather than starting another
Oops.
species, I think it might be a good idea to continue with this or ask y'all's questions.
Yeah, let's do that. We won't start another species, and next time we can continue with some of these others and look at some of these distinctive features.
So by the way, that was an announcement that I realized as we were going on that maybe should be said. It's going to be 3 weeks again until we meet, as next week is Juneteenth, and then we're teaching a class, and then I am taking July week off.
Okay.
So heads up. Glad you got here. Don't forget everything you just learned.
What's next week?
Juneteenth on Wednesday.
What's on Wednesday?
Juneteenth.
What's Juneteenth?
It's a federal holiday.
Oh, it's a holiday.
Of reparations.
Holidays. Okay, got it. I didn't know we had that holiday. I'm so out of it. Okay, any questions? Yeah, and I think I have gone from like, oh my God, not another Trachandrena to like, oh, Trachandrena, pretty straightforward and enjoyable. And yes. So and I just think you may want to do this kind of thing on your own for some of these groups that you struggle with. Like you can create your own kind of guide here.
Yeah, we've seen that while it was not shareable, Karen Wright walked us through it with Melisodes back in the day. Interested if anybody else has like the way that they make their own personal notes or whatnot.
Yeah, or keys.
Love to hear from you.
I'm gonna stop sharing.
I guess my last thing, since nobody's asking in the chat, I'm starting to ask in these reminder emails. The video automatically generates a transcript, but it is about as good as you might think it could be for the technical terms that we use. So if anyone has connections with computery people who could maybe train a program to understand what we are saying, or undergrads who could sift through and at least get species names in there so people could control F, would love to hear from you. Okay, thanks. Bye.
All right, I guess we're good. Thanks, everyone. See you in a few weeks.
Hart Miller Island, if you want to pop in, but I'm going to stop the recording.
Oh, okay.
So, Jean, if you want to talk, we can.
Oh, yeah, Jean, I emailed you and you did not respond as far as I saw.